Today we're going to be talking about the derivatives of inverse functions, and it can be a really confusing lesson. If you look on page 470, it reiterates to you that every one-to-one function has an inverse. Okay, remember, a one-to-one function means that it not only passes the vertical line test, but it also passes the horizontal line test. So a parabola is not a one-to-one function. The graph on the right hand side there is a one-to-one function because it passes both tests. So if it does do that, then the inverse of that function is mirrored over the line y equals x. So on the bottom there, they kind of try to show you what that would look like broken up into pieces, just for the one that's on the right, because the one on the left is not a one-to-one function. So on page 471, the formula that we're going to work with is the derivative of the inverse function of x, that's the derivative, is equal to 1 divided by the derivative of the inverse function. Alright? And in bold black print it says, the notation can be confusing, but the important thing to remember is that the slope of the inverse function, that would be this right here, the slope of the inverse function equals the reciprocal of the slope of the original function. Alright, so let's see. They give you a couple of examples there. Let's just go ahead and look on page 472. It says the function f of x equals x cubed plus x minus 1 is a one-to-one function. So we don't have to determine that. Find the slope of the graph of the inverse function at the point -1, 0. Well, the first thing we need to do is find the inverse function. So remember, to find the inverse function, we first of all switch the variables. And remember, f of x is just y, so we change that to x. And this becomes y cubed plus y minus 1. And then we'll take the differential of that, which would be dx equals 3y squared dy plus 1 dy. And we want to solve this for dy dx. So we want to divide everything by dx. So that'll be 1 equals, and now we can factor the dy dx out of 3y squared plus 1. And then to get dy dx by itself, we'll divide both sides by 3y squared plus 1. Alright, so that is the derivative of the inverse function. Okay, we found the inverse function, we took the derivative of it. So the derivative of the inverse function is equal to 1 over 3y squared plus 1. Now let's see, it says to find the slope of the graph of the inverse function at the point -1, 0. So now we just plug in -1, 0, so this would be at -1 will be equal to 1 over 3 times 0 squared plus 1, which is just equal to 1 over 1. So it's equal to 1. Okay. Next, 92.2 says, let f of x equal x cubed plus x, and let h be the inverse function of f. find h prime of 2. Okay, so here's f of x. We need f prime of x. So that's 3x squared plus 1. And then remember, h prime of x is, and let h be the inverse function of f. Okay. So then h prime of x is going to be 1 over, we're just plugging into the formula, 3 times h of x quantity squared plus 1. This is an x, sorry. So then h prime of 2, which is what they want us to find h prime of 2. We just plug in 2. So this would be 1 over 3 times h of 2 quantity squared plus 1. Alright, now, but what is h of 2? We didn't find the inverse of the function. So we need to go back up here and find the inverse. So the first thing we do is we change the variable. So that would be x equals y cubed plus y. But if it's at h prime of 2, so actually, before we even do that, we could just look at this function. It doesn't happen very often, but if we look at this function right here, f of x is equal to x cubed plus x, and we want that thing to be equal to 2. If we want that thing to be equal to 2, what does x have to be? X has to be 1, right? 1 plus 1 would be 2. So that means that x has to be equal to 1. So now we can take that 1 right here and replace it, because that's what h of x is equal to. Alright, so if we come over here, we have again h prime of 2 is equal to 1 over, now instead of this being 3h of 2, we know that it's 3 times 1 squared plus 1. Because we plugged in 1 for h of 2, because h of 2 was the inverse function when x is 2, but actually remember the inverse function, the x's and the y's change position. So that's why this 1 plus 1 is actually a y value. So that's the inverse. Okay, so what does this simplify to? 1 over 4. Alright, now it says, had we been asked to find the value of h prime of 12, we would have been in trouble, because if we put 12 equals x cubed plus x, we don't have any idea what x is without solving it in the calculator. Okay, but because x cubed plus x equal to 2, then we knew that this had to be 1 plus 1. And I believe that all of the examples that you have and on all of the tests, they come out to be where you can actually see exactly what the number would have had to have been. Alright, thank you guys. I know that's a super confusing lesson.